Yo. Receiving your content. Unsupported resolution. Brilliant. Okay, unsupported resolution. Can the internet see me? It looks fine. Is it really an unsupported resolution? I'll make them fix it. Output. General video, I think. Oh yeah, it is a really weird resolution, isn't it? Hang on. Okay, there we go. Okay, so I am reversing PlayStation Suite encryption. And so I have been doing this for the last few days. I've gotten somewhat far in my it's a huge process really. But yeah, Ghidra. Ghidra's been annoying actually. Ghidra's been very annoying. Let's pop out the chat. Okay, let's go on Discord, I guess. Let's see what people are doing over here on CBPS. Ghidra 1.9.1.2. Is that the latest version? I think updated since then. Ghidra. I mean, if it's it's still version 9.1.2. Okay, and it is incredibly annoying, this version, because here I have the Android version of PlayStation Mobile. I have the main library it uses. I'll see if I load this up. It does seem very annoying, this version of Ghidra, and there's not much I can really do to fix it. I think it's related to object-oriented programming. It probably is. You know, but basically, the reason why we use the Android version, by the way, to reverse this is because it has all the symbols, all the function names. So if you look in here, right, it's all the function names. Everything is named. When the Vita version just has the library name and then the NID. So, so immediately when I saw this, I went and searched for eData, right? Because that's what Sony calls PSSE internally. And you find a bunch of stuff when you do that. Good morning. What's for what? This is PlayStation Suite encryption. It's the encryption on PlayStation mobile games. Okay. So you'll see there's some interesting stuff in here. I already found the key store. So if I show you this, PSSE header key store, right? If you drop this into hex editor, you come up with this data blob, and somehow this gets turned into the key, and that's kind of what I'm trying to work out, is how this data gets turned into the actual key to decrypt the file. I've tried just grabbing candidates because the algorithm is AES 128 CBC. So the key is only 10 bytes. 0xf bytes 16. But you know. So basically the file I was looking at was you can see a bunch of stuff about how it opens if I could find these actual functions on I'm tempted to use this to try improve PSM patch at some point as well. But the main thing is these tfit functions are annoying as hell. And it doesn't look like any standard library, unfortunately. But if I look at this process header, right, this is the JNI. This is something JNI does. It creates a function that can be accessed by Java, and for some reason, when it does that, it always just calls the other function with the exact same name. So yeah. So there we go. And you'll see here it is this is ginormous if statement. Yeah, so it checks if the first header is P, then the second one is S, and the second one is EM, and the second one is E, so PSME. Or if the first header is P, second one is S, the second one is S, and then the third one is E, so PSSE. I'm not quite sure what this data is. I often, when I come up with things like this, is I just set them to be equal to their value. This makes it way easier to follow. Okay, so you know, I'm actually not quite sure what some of this is for, but the main thing is after this, right? After all these checks, right? It then comes down here, and it mem copies, you know, this times some straight exchange parameter plus 10. This is all still one argument. And then this offset plus this. This is the annoying thing it's doing. It's doing an offset plus some other offset inside a like a certain memory location, and that's really annoying whenever it does that. But basically, in order to work out where this is, you have to copy this yourself manually and paste it in here, and then boom, you find it. This is actually m manager, m_manager. So let's add a comment. Set m manager. There we go. Now we know what that is. So you've seen I've done it here. This here is the IV. They've got the world's most secure password ever as their IV. You know, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, the part that the IV is 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is where I found the this is where I found that key store for decrypting, because this is the Android version that conveniently outlines to us that this is the SC crypto library decrypt AES 128 CPC. So it tells us this is AES and it's 128 bits and it's chain block cipher. So that's very convenient. But if you look here, what would normally be passed as the key is actually this giant thing of data, and this is definitely more than 128 bits. So somehow this gets turned into the actual key, and I'm not quite sure how. And this function I've been reversing, so I've been reversing this, right? And this is what's really annoying. So it goes into this tfit engine, create from exported, and here you get this joy. It you know, it gets this pointer and it calculates this pointer based on the tfit engine generates secure data. The actual function here, yeah, is completely irrelevant, the function here. All that matters is the address. So this address right here. Okay, so the actual function that it's pointing to doesn't matter. So you go out and then go see it's cast into a pointer to a pointer. So the pointer of tfit engine generates secure data, right? That's a pointer, and then plus that, and then this whole thing is also a pointer. So I guess I could specify. I already do specify that. Yeah. So that's and then it's that plus this many bytes, which if you look at, I incorrectly got stuck at this for a while because I incorrectly thought that it was actually referencing the account ID. However, it is not referencing the account ID. It is doing something else. You see, now I get set, right? So this is what that is. That points to here, yeah, and this points to here. So for all crap, the account ID is involved somehow. But no, it's not, because right down here, I equals I plus 1. So this address plus 1. So actually, this address, right? And that's called by other things. And it's written here. So I looked through the write thing to see what writes to it and what gets written to it. And so after that, it then jumps to what's in this location. Alright? So it jumps here and it calls the function at the location I plus 0x1c bytes. So basically what gets written here, if we have a look, is there's a whole bunch of stuff in here. This one is this one. I guess in here is actually this one, surprisingly. And so the value of this is the one we need, which is this. And then if we, retype, if we do that and then we calculate this whole thing, I don't think this is actually right. I think I did something wrong here. Yeah, you end up here. And then there's this whole bunch of functions, right? And half of them just return and do nothing. Like, literally the majority of these functions just do absolutely nothing. But then there's one somewhere that actually does something, right? And that's what I've having to be dealing with this whole time. So I believe the one I was looking at, the process whatever, right? This one, right? I found the first place it calls is here. The final create data table. That's the name I gave it. And the only function that matters is this one, create export. So always ones just do nothing, but this one, and you see it goes through the whole list. This one actually does something. So I've been looking at some structs, and it takes in the key store, it checks the keys. This is the weird thing. It checks the key store here, does absolutely nothing with it, and then if this fails, then key store is set to this. That's it. So it doesn't. All this other stuff here, I could calculate a whole bunch of byte arrays of this weird function subsdi that like takes in the buffer and then does some math on it. It's just hella annoying. Why can't they just do AES like everyone else does? PSSE is the encryption on PlayStation mobile games. So yeah, I calculate the first few addresses here. So the first one that goes in, this is this argument, right? This argument is this buffer here, and you see it's some sort of data. It's like a bunch of 6s and some 2s and whatever. And this one, this is the second argument that goes in here. It's a bunch of a bit more data. And then this one, for some reason, one of the arguments is in the middle of a jump table. I don't know why. It just is. And the thing is, what this function does is it's weird. Like the jump table is using the first item in the jump table, right? And star jump table is equivalent to jump table in bracket 0. So there's reading the first option in the jump table, and then that's being written to this outputs for some reason. And so I was like, okay, I want to see what this is doing. So I grabbed myself Visual Studio, right? And I re-implemented this whole algorithm in Visual Studio to, oh, and also does this annoying thing with a buffer that's calculated based off an offset. That's actually this one. And it's a very large array. In fact, it's actually bigger than Ghidra recognizes it being. So if I open this up, secure data array.sln, right? This is me trying to re-implement this exact thing. And so I basically remade this algorithm. If we load, any day now, Visual Studio is very slow. Whatever. Basically, I recreated this algorithm and it just segfaulted. Like, I gave it all the same inputs. I gave it does all the exact same stuff, and it just segfaults, which is like great. I am going to. I think I have an idea on how to fix this though. I think what's happening is the buffer here is grabbing extra stuff from memory or something. So what I'm gonna do is I'm gonna actually like gidget open the entire like elf binary, right? And I'm gonna specify the offsets, like exactly as it does here. Right? Specify these offsets within the binary so it actually works the same. In fact, I'm gonna go do that right now. So here is my recreation of the algorithm. It's based off IDA's decompilation, but it's basically the same. So you see, it's like it does the same thing. It gets this, it does, so that sets this buffer to 128 times whatever, and then it pluses this, plus that, and this ended by 0xf8, and output equals kilobyte and 97. It's the exact same algorithm. So here is all the arguments. Here's a mem setting at first, and then this being called in, and the output's here. And when you run this, it just gives you an error. Doesn't even work. Hi. Ooh. And so like something that would very, very, very much be helpful, would be if I had, right, if I had an Android device that had PSM games on it that still worked, and it was rooted and I could somehow run a debugger on it. That would be incredibly helpful. Yeah, see this freezes because I have a breakpoint on this mem set. And we go into this function, right? And you run through it. It runs through it a few times, and then it just errors. It gets here and it just goes nope. And it's because it's reading from such a giant offset into this buffer. Like it's reading more than is actually in here. And so what is encryption? Basically it's like, I hate using this analogy because it's really unhelpful, but it's like if you have like a yock, right, and like you yock something, the key, you can't like unyock it without the key, and like it's like that, but like in computers, and so like every game has its own key, and like you need that key in order to unlock the game in order to play it. Otherwise, you can't. You just get like gibberish data out from it. Yeah, it's hard to explain. um, but basically, right. So I've got app exe here, right, and this is encrypted, right? You see in here, this is just meaningless, right? This is all just random bytes. However, on an actual exe, it would make somewhat sense, right? It would have like actual structure in there. So like that's the difference. And decrypting is when you get this normal data back out of this random mess. It requires a special key in order to do it. So that's what I'm trying to work out right now, is how to do that. So, see, this errors. So, here is what I'm going to do. I'm going to load this. Here the offset is 1000, is 800, 000, 10000. So, instead of doing this, I'm going to actually specify this buffer as a offset into this binary. Basically exactly like these people do, exactly like it does in the code. So where did I put it again? That's right, it's in here. This is where my, and then PSM, whatever, yib, EABI, yib default OS. Okay, we're going to copy this off. Instead of doing buffer like that, we're going to comment out byte buffer. That's not how you comment in C. I'm going to a byte buffer, byte pointer buffer. Now I can file fd equals fopen. Of course, it's being annoying with escape sequences. So I put an at here, does that stop that? No, that's just in C#. Let's do this manually then. Yeah. Mode will be open for reading. Okay. And then how big is this file in bytes? That's 11 megabytes. Might cause problems, but malloc. It's malloc a buffer of that size. It's set buffer equal to it. There we go. And now fread, and then buffer that size. One element, and the file is fd. And then fclose fd. Okay, that should work. I should read that file out and into that buffer. And now maybe if I now specify in here, right, that the buffer, just like it does in Ghidra, how it does this, right? All I need to do is basically the same thing. You can do that. Except there's one other thing that we need to do before that, and that is we need to minus the location in memory from here. So minus 0x00, 01, 000. So that should work. And that should be reading it basically directly from the file. One issue is that buffer2 is an argument. So buffer2. Okay. So maybe, maybe that will work. I'm gonna give that a try. I'm gonna set this here. I'm gonna run. I'm gonna see if it lets me malloc something that big. It gave me a builder. Mention maybe CRT secure. How do I do that? I don't care if it's unsafe. My code's fine. CRT secure, no warnings, Visual Studio 2019. Let's add a define for that. Okay. Here we go. Is it 1? Builder. Why? What? Being ridiculous now. It's not a warning, right? No, it's an actual error for some reason, even though it should be a warning. Ugh. Let's do that. That doesn't work. Into the preprocessor. Okay. This is all programming is, guys. Just go on Google when something doesn't work, and you just paste in, whatever it says to do. Alt F7. Oh, it said Alt F7. Alt F7. Properties. It doesn't want to work. I'll open it this way. Properties. C, CF, C++, preprocessor. And then what do I put it under? Preprocessor definitions. Okay, edit. Adds in that one. And now let's save, and hopefully it will compile now. I don't care if you think it's unsafe. Yay! It worked! Okay, so now we're here, we go down, we malloc, it actually mallocked something that big, that's surprising, we f-read the entire thing into it, and now we can actually, this is actually, so far so good. Test program, where's the code now? Did I miss something? Okay, let's go down, let's go down, let's go down, 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 into this function, and run through it. This is actually working. It's not even erroring. That's actually brilliant. And there we go. We can now print out the value that was calculated. This is taking too long. Right click, run the cursor. Alright, there we go. So that's the entire output. That's odd, because it looks more or less the same. Right? It looks pretty similar to the inputs. That being the input right there. I just want to make sure I've got this at the right offset. So I'm gonna copy the code from Ghidra now instead of Ida. I think it will work better. Let's take this subs di. I just trust Ghidra's decompilation more. Let's make bomb always minus 0x00100. And there we go, that should do it. I need a hard-coded addresses. In fact, great thing about doing that is now I can actually go back into the function this calls from, right? Because I have a reference to this file, I can actually go directly to these offsets. As long as I rename all of these to be the value they actually are, right? This will work. I just have to minus that specific value off all of these numbers at the end. And there's a really simple way I can do that. I can just make argument why this messed up and change a bunch of values to that. It shouldn't have been that. It's undo. I undoed a bit much. Right, here we go. So then I'll go here. I'm actually select the right. 1 minute. That. That one. All these. And then as long as we more or less can set up this exact same exported key structure, and we can get the output of all of these. And then we can just not worry about the sub STI script function anymore. Because we can just implement it straight up. This is actually genius. Why didn't I do this earlier? Let's open all of these. Let's open all of these DATs and change the name of the DAT to its offset. Okay, and now the same here for these. This is way easier. This is just grab all these values, all just ints. There's always int pointers. All of these are just int pointers. Okay. If I retype this to int star, does that do anything? No, it doesn't. Alright, no point then. Okay, so let's actually change this dialog set a bit. Let's grab all these now. Actually, let's rename this to be 0x self. This to be 0x itself, and these all be matching, and this to be 0x itself. Okay. So now, all I have to do is copy all these. Ignore all of this. I can just go down to here and paste all that in. I'll import the exported key structure. Export key structure is here. So if I go down, it should be under PSMSC PLX or ELF. Is under there. No, it's under auto structs. Yes. What is this a structure of? Secure data struct. Okay. Export C header. Yes. Let's export that into source repros secure data array. Secure data array. Secure data array. H. And now we can add that. There we go. And we can just copy its declaration right here. It's great when things work out. Now we imported that. Let's not bother with that. Right, so now we've got all these exported keys. We want malloc. I want to set it to malloc. Is malloc size of secure data structure. We just want enough memory available for it to do that. So there we go. That should do that. Now, here comes the magic with these stupid offset crap that Ghidra does, right? All we need to do is go into the upset sub STI function. And we're gonna make this take integers. Int, int, int. I'll call them out. I'll just call them I1. That should be I3, I2, and I1. Now, buffer 1, right, star buffer 1 equals I1 minus 0x 0, 0, 0, 1, 0, 0, 0, 0. And then we do the same here. 2 and jump table. Let's make that I3 and that's I2. Okay, and now all I want to do is head back here and change this. I have to make sure this is doing the same thing. So that's an int, that's an int, and that's an int. So what happened? So here we go. We got this output. And so I'm making this copy this more yes directly into here. And that should maybe work. Let's hope so. And that should spit out all the exported keys in theory. Actually, I saw some mistake in here. I need to make this equal to. Yeah, make sure these are all equal to byte buffer, right? Let's call this vmem. This is like a virtual memory, right? So got that. So that's like what the thing is in memory. Let's be vmem plus vmem plus and vmem plus. Now that should work more or less exactly the same. So I can now run through and read out all the byte arrays, and I can continue on knowing what the value will be. Accepted error. Where's my error? Char followed by char is illegal. Guys, the police are gonna come. I broke the law. I broke the law. This doesn't like some of these definitions. That's no problem. I can just move them. Yeah, there we go. So open up your default.so and we just read out all the stuff directly from it as if we're the application. I mean, it works. Alright, so we read this out, we read vmem, and then we run through and we error. All this is error for access variation jump table was 0 to whatever. Oh, it didn't like me. Kiwi. So let's try breakpointing here just to get this right. So right now, buffer 1, buffer 2, and buffer 3 are equal to these. So if I set that, that's not equal to vmem and a certain location. That's set to vmem in another location, and jump table is equal to there. And people looks to be set to an invalid address. Is that correct? It looks correct. But then errors once it gets there. We need to cast this into a byte pointer. Is that what we need to do? Trying to get the pointer an offset of in the binary. How much do you earn? Me? I don't earn anything. Why would you think I have a job? Okay, here we go. And and it gets a thought on this one. Let's open up the binary then. Let's jump to this location. Finish. Yeah, it doesn't exist. That's this one, right? It should be B7AC. That's what it should be. What is I3? I3 set to that. Can we even go there? If we go decimal, it doesn't contain the offset. Huh. That would... Let's manually do that. Minus 0x0001000. Let's jump. Okay, that exists here. But then... Is it because I'm adding this to it? Just this. Should be me. Okay, that doesn't actually exist. Interesting. So the address being read here, this third argument, doesn't actually work. It's here, which is undefined 1 in an unknown location. In the middle of nowhere. I mean, I guess it makes sense that it doesn't work. Is that an output? Like, maybe it's actually an output. But no, it can't be an output because it reads part of it. Why would it do that? Why would it break everything I was trying? In the middle of nowhere. It's in the middle of a undefined 1. Like, it's just a random undefined 1 here in a huge array of data. Like, what? Okay, let's go back. Let's see where this thing comes from. Is that a hex address? I don't know. What is this minus this? Why isn't this working? Be a calculator. Thank you. That's the hex. I don't know if it's hex. It should be hex. Yeah, it's hex. Let's go there. That's M manager. This whole thing is M manager. Yeah. This whole thing is M manager. Okay. So somehow a M manager thing, a huge variable, gets written to what writes to it. Why can't I? It's just curiosity compilation. Why the hell can't I see this properly? Just move to the side. That's be annoying. Ghidra! I should be able to read this way, but I can't. I don't know what writes to it, because I can't see further than that. Let's look like these are all rights. There's a lot of rights here. There's a few places in the API process header. If those are rights, so now people are looking for. See, this is the problem with object-oriented programming. I gotta go for a sec. I gotta go for a sec. Be back soon. fuck's sake. Hang on. Okay. I am back. Oh. So. I was looking at Control G, yeah, M Manager. Function. It takes in a bunch of data from here in the middle of M Manager. This area of code here takes in a share of data from here. And we all know this comes from M underscore manager. Work that out. M manager. Okay. So in here we need to find, what is it, eData process header? Yeah, it's used here a few times. References this here. And it references it, is that right? LD. What does the LD instruction do? Is the M manager being what's being written to? So what's uval1? It says a puval2 1. Just whatever. How about this one? So these are both being set. It's in this weird block, but I didn't quite understand what it was doing. If this plus this, which is M manager directly, plus, so M manager plus this offset plus strange param. What is the value of strange param? Well, it depends on what you set the value of strange param to. But it's a very easy way you can find out. Just look at what calls this function. Then look at what calls that function. Just eData API open. And then look at what it says strange param to. And strange param is, well, it's and stack 0xFFFFFFF0 plus that whatever, which is another bunch of F's. So that's strange param. Which is, I was kind of hoping to be something a little less ridiculous. So what is this set to? When is this set? When is stack 0xFFFFF set? I guess I could guess that's why I call it strange, because it was, incredibly weird. What's it say in assembler? That's always a good test. So in assembler, this is just a yod from yod to AL12, the offset of AL12 and pound for. And this is the other power. So this part here is right here, and then it subtracts 0xc, then it loads this into our 12, I think. Or is it loading? It's loading the address of these into param 4, I think. I'm not quite sure what this does. I'm not very good at ARM. Unfortunately, I'm terrible at ARM assembly. I can do x86. That's easy. x86 is very simple for me. But yeah. Where is the stack variable set? Let's rename this to. I can't even rename this variable. You know, I actually can't rename this stack underscore whatever. A common thing, however, when there's a weird stack variable there, is that sometimes it means there's actually an extra argument. So let's try adding an argument. Let's try doing that and see if that changes that weird stack function. It did not. It just, well. What would possibly be in the stack at this area? And why in such a weird place? Like FFFFFFF. Sometimes when you see arrays like this, it's a good idea to combine them. I'm going to just do that. A lot of the time these arrays, like they're really close to each other, are actually just one big array. So let's copy this. Let's retype this to let's plus this. You can't do that? Okay, I'll just manually calculate that and then set that as value. All the time, that's the thing you have to do. Retype cha. Rename cha ctx. We get an idea of what that is. So this weird stack variable, it's not used, it's not set anywhere, and there's no extra arguments in this program, in this function. Data open is used by the data file open. That's not surprising, but I really gotta find some of these functions a PSM patch at some point. A basic key just reads you know, this is what reads the header. Alright, processes the header in here somewhere. Yeah, it SHA-1s it, and that processes the header. And header supposedly contains heaps of useful info, but if I can't work out what this stack variable is, why is this here? I can't possibly work out, but I'm gonna just Google what that stack thing means. Yeah, let's just do that. I'm sure someone else has come across this before. Doesn't that mean it's getting the address of the stack? Hey, Joshua N. I'm hacking PlayStation. Gadra. No, I want this exact thing. Stack. Whatever. Gadra. What does that mean? No one else has ever complained about this. You know what? In times like this, you bring out either. You just use a different tool to decompile it and see if it gives you a different result. I did find that a lot of the time either will calculate these things for me, which is very helpful. So if I can get it to do that this time, that would be great. so I can work out what a strange param is. Let's just kill this. Don't need that. So if we open this up, do data open. SCE PSM eData open. That is the function, right? SCE eData. Oh, eData API open. eData API file open. Sorry, file open. There we go. That's the function. So this is this huge function. If I push F5, does it decompile? It does. See, it tells us. So now we just scroll down to see it does something with the public key. And here's what processes. Here's what processes the file header. And you see this is just v9 at this point. So we'll rename this to strange param. I guess we can specify all these types that we know for the whole thing. So we know this is the header. Let's rename this to header. And then we rename the last one, which is just a void pointer to somewhere. I don't know what that one's for yet, so we'll leave that. So if eData process header, then we eData API goes. Is that the same line we're on here? Is it? I'm guessing it is. It's right after the SHA-256. Yeah, okay. So here it is. So strange param. What is strange param set to? Let's go up a bit more, bit more, bit more, bit more, bit more. Where is it set? Strange param distance there. Strange param. Point to the strange param is equal to -1. So that's what it's set. It's equal to -1. But then it runs through here, and this whole bit of code seems to set up this M manager thing. That does something with the signature. Maybe we can patch the signature check. Yeah, I mean this is clearly the function that checks the signature, right? Because it takes in the signature public key, and then this is definitely the output of it. And then that's the size, and 0. It just calls. Perhaps that'll be something to look. That'll be something to look into. Once you work out the decryption, the crypto. Once you work out the crypto, you could patch this check out, and then you'd be on mod PlayStation mobile games. Fairly easily. There's a bunch of stuff here. It seems to put a bunch of stuff relating to the M manager variable here. But one thing I want to check is if this variable is even what I think it is. Oh, I didn't mean to close that. Oh, crap. I didn't mean to close that. Okay, so it was export keys, I think was the name of the function in the end. Forgot what I called it. Key. It's create exports. That's right. Create exports. That's what I'm after. Create export. There we go. So I want to go here. I want to check this function, create export. So it's the same function in either. And you see in here in either, it recognizes immediately this offset, and it says it's here. So here's the idea. These are direct offsets right here. As long as we set these all to be child pointers. No? What are these? Oh yeah, specific sizes. Or whatever. We just call this. Alright, so this offset here isn't actually the right one, apparently. So all we do is we just copy that in. And then we can change this to specify directly that this is what we wanted. Why am I manually doing this when I can do this in bulk really quickly with Notepad? Forward this to Twitch. I don't have Twitch. And Twitch is more for gaming. This sort of thing wouldn't work on Twitch. So let's just replace all chow unks with 0x. And there we go, it changed a whole bunch of those. And now we want to replace all int style offs with 0x. And then there's just a few more here. Chow style off. Replace all. And then we're going to replace all chow pointers. Nothing. And then we just want to replace sub whatever with SUB-STI. And now I just want to paste that in there. And you can just do that. And now I can just head over here and remove this part where I mine this whole bunch off because Ghidra either loads it in offset 000 if I'm incorrect here. And yeah, it's working. So brilliant. We are getting our buffers out. So Ghidra just had the wrong offset, apparently. We just run through, Now we can look at the exported keys. If we scroll down a bunch under we should just print these all out. But yeah, Ghidra just had it wrong. You don't need to worry about that giant array. I thought it odd that it specified a specific location in it, but it didn't show an xref there. So yeah, here we go. While one, while for int I equals 0, I less than 18, I yes. Okay, and now we're just going to printf percentage x2, and then just I. And I can just do this for all of these. Printf Sanjan. So that should give us the first key data. We just set a breakpoint now, and now run this. We should just get the first one outputted right away. And there we go. I gotta make sure that's the right offset though. I don't wanna. I wanna make sure it's actually, this is actually at this location. So here it is here, and supposedly it's 663 whatever, right? And if I just jump to this location, I have to make sure this is correct, that it's in the right location. So I'm going to manually verify this bit of data. So where we are is exactly 663.506 whatever. So this is correct. It calculates the offsets correctly. And so the output of this is the exported keys. And in fact, I'm going to open up this subroutine. I'm going to probably specify the rec key in here as well. I just want to make sure this is all using IDIS code. Let's copy that. Let's make sure this is the correct offset, I guess. And if I go on here and I jump to this part of it, I come up the start of this huge array. So yes, that is correct. So now I can just print out all the exported keys. And yeah, that should just give me all the secrets. So let's just repeat this. 9 of them. Just put a bunch of those down. And then we're going to print the first one. Then we're going to print second one. Third one. I'll print fourth one. Fifth one. Sixth one. Seventh one. Eighth one. Ninth one. I actually managed to paste exactly the right amount. That is impressive. So the only weird thing is that that's an 8 bytes buffer, right? It's an 8 bytes for the supposed exported keys. 8 bytes is a weird amount for a key. That's 18 bytes, I mean. What is 18 in hex? 18 to hex. It is 0x12. 0x12 is a very weird amount for a key. That's the only thing that I find odd about this, is that 18 is a very weird number of bytes for a key. So maybe it's not 18 bytes. Maybe, but it clearly says 18 now. And that's clearly the size, because it's checking if the offset's not equal to the size. Why use different arrays for the same one? You can just make one line between them for loops. Because you can't just byte out ++. Well, maybe you can, but this just will work just as well. So now if I open this, it should just give me all the keys. They should all just pop out to me. The weird 18-byte keys that I can't help but feel aren't actually keys. But hey, I know they're useful somehow. So there we go. There's all that exported key data. Brilliant. let's malloc all of this. Let's copy that into a hex file. Boom. See, the thing is that the keys only they stop here, right? 06, 12, 12, 52. It's like 0x12 bytes for some reason. It's like an extra 2 is what I'd expect, because it's AES 128 CBC. So I'd expect like an extra whatever. There's a bunch of O's, a bunch of B's, there's a bunch of BL's, BL. Very interesting. I do wonder what they're doing here. But now I've basically reversed this part of the program. This whole part. I don't need to touch this anymore. Oh, and I forgot to show this other thing. Either says that this is set to key store 2, but Ghidra says this is set to 0. And so there's a chance the exported key struct has a copy of the key store in it, but there's also a chance that it doesn't. Means would make this make more sense, because it checks if key store is valid, but then does absolutely nothing with it, which is odd. So I'm going on the assumption that the key store is in here, just because it makes more sense. So now we've got these keys out. I'm gonna write these out to a file, each one of these keys, at some point. But yeah. And if they turn out to actually be the keys, I think they are, I'll put them on the wiki. So that's create export done. I now sort of get what this thing does. Now if I go back to that tfit function, tfit. No, it was SCE crypto AI berry AES 128 CBC. Not quite. SCE crypto. Let's just search that. There we go. Decrypt AES 128 CBC. Okay. This is the annoying thing about object-oriented programming. So it takes an export keys handle, accessing the exported keys key data, and this key data is what we just calculated here. Right, exported keys. You'll see in where is it? In here. Key data gets set. Key data gets set to exported keys. So it gets set to this struct with all of these byte arrays in it. Key data gets set to this. So yeah, just keep that in mind. So in here, it does more or less the same thing as the other one, where it gets some weird variable and adds 1 to it, and then like, it starts here and it ends here, but then it adds 1 and then it goes 28 into it. I really don't know why Sony felt the need to do this. It's probably just an object thing, because OO is stupid. But I really get annoyed whenever I see this. Like, it really pisses me off. But as long as I can find what function it's really calling, then I'm good. So this is the create from export pointer, and that's the one. That's the yast offset. So that's yast off. And this is curl off, and this is return. This is ret val. There we go. Now it all makes sense. I'm gonna make that a yes long name, so that's ret. That's just ret. And then it gets a function pointer based on the current offsets, and then throws all of these things onto it. So current offset equals current offset plus 1. So this is actually a for loop, despite appearing as a do while loop. So let's jump here. So this, and then so that's the last offset. So the last offset, and that's a pointer to a pointer. So it's the pointer at the value written here by this function, which is create crypto from exported. It's final create crypto from exported, I think, is the one that's after. Whatever's at this offset. No, that's the offset that's written to right. Gen handle. So in gen handle, it's what gets written here. Yeah, this is it. So this is where it ends up. This is the last one it wants to be on. So let's just take notes. Let's just put that in there. So that's the final offset. And this is the current offset. This is where it starts. It starts at count ID again, but plus 1. So here, so it actually starts at this data set, which is written to by this line here. We get set handle what's up here, which is from this here, which is from this one. Maybe not. Maybe this one. One of these. And this one gets set to. Yeah, this one makes sense. This one's better. This one makes more sense. So this is the create cipher jump table, probably. That runs through until it's here, I think. Until it hits case. Rename, edit able. Create cipher jump table. So that's what gets written here. So it's what's read by here. So it's the offset there plus 1. And then plus 28 each time. So create cipher, and it adds 28 each time it tries to run one. So it's actually this offset. It's actually the offset of this jump table. Right. B745A8 plus 0%, which is here, this function. This function gets run, and then this function, the function under it gets run, and then it was reading invalid memory. So you better hope this is the function it wants. And it is. This is the function we want. So yeah, this is the actual create cipher. Create cipher. So this is the create cipher function. So let's edit this comment and set this to be comments set create cipher. And let's copy this function signature. As apparently it's already got set this way. Okay. So some val 2. So these are all those weird flags that we saw. Just a bunch of checks here. What's this? It seems to do a bunch of stuff with that subci function. Again, interesting. Let's ignore that for now. Let's scroll down further, because often what you want is around here. And so this creates this, which, okay, there's a bunch of stuff here too. Bunch of stuff going on in there as well. Okay, so now I've got a basic view of what this function does, right? So, key data. Where is the key data used? Is the key data used at all? This is just a quick way to check the right function. You look at things that you know would have to be used, like the key data. Is it being used anywhere? No. How about the cipher? Is the cipher being used? No. So that tells me this is probably not actually the right function. And how can you remove real name entry on PS4 and only show your ID? Okay, so like what you do is you open up this program, right? And then you just click the remove real name button. I know, it's crazy. Like you open this up, right? You log in, and you can even click on this. Sid is hotmail.com. And then it doesn't work because Sony broke it. So there's a bunch of stuff here. And it doesn't seem like the thing is that this create cipher function doesn't seem to use the cipher part at all. Does it use it in the assembly and I'm just missing it? Handles used in the assembly. But that's it. So something with this tfit create cipher function is not correct. Maybe it's not that. Maybe it's a different case, and I've just got this calculation wrong. But it's the only thing that makes sense. Maybe it is to create cipher. Maybe we can just. Maybe it looks different in either. Maybe either will save the day again. I broke the decompiler. I went to the wrong offset too. It's this minus there. This is where I actually need to be. But it doesn't work now because it's broke, and I just dumb. If it breaks once, I have to restart the entire program. People say this is commercial software. Imagine buying either and like having always 3 problems. Okay, so here's the subroutine we want. Decompile. So now we want to edit this function signature to appear the same. So I'll rename this first one to this is I. The second one is handle. Third one is int some val 1, some val 2. Some val 2 and some val 3. Now, here's the thing, is that these other two functions apparently, these other two arguments, apparently aren't even part of it, which is interesting. Are they even sent? Yeah, they are. It's definitely sent onto it. What tfit? Why does this tfit thing look like an item? Tfit create I'm going to create ciphers. Let's see here. It calls from here. B13 equals B12 1. So it equals this. See, either detects immediately where this is coming from. Either detects it's here. And all of these, just add to jump table. And then this is V13. So that's the co-offset. So, either sees takes the current offset, which is from here, takes the first option in it. So that would be this one. This create data from wrapped function. This is the first option in this array. So after that, if we want to make that clear, we can specify that this is a word. Probably. Okay, so it takes this and it adds 1. Word is an int 16, isn't it? Yeah, I had that wrong. It needs to be a D word. Yeah, see, so +1 here, which is this. And then it gets that offset. Actually, I guess the int that's pointed to here, which would be this. Right, because this is an int pointer. And it's pointing to the location of this, which means it's pointing here. It's reading the first entry. It's reading here in the first entry, which is here. So it's actually got the pointing to the offset of this. And then it adds 1 to the jump table. So that's basically what this is basically the same as this. And then the result is the current offset plus 40 bytes. So here Yes. 20. And I didn't like that. Let's make that a 0x. So there we go. That's here. Inside this data xref, which is written to which is what's written from here. So this is create cipher, and it's written, so whatever's written to from here, which is oh, it's this value. No, it's this value. Yeah, this looks like a jump table. So this is the create cipher jump table, and it runs through here all of these functions. Look, it's one that isn't ridiculous. So that one just returns, that one just returns, that one just returns, that one does something, that one. What does this one do? Oh, how interesting. There's two functions here it could be. Ooh. Anyway, let's head back. So we know it goes from here 40 bytes, right? Or does it? No, it runs through all these. So yeah, let's just go to this. This is jump here. Plus 0, 0, 0. So that's here. So this is the real create cipher jump table. This is the real create cipher jump table. Let's edit this set this comment. Yeah, that's what it's like. And it runs through, and if the return value is not this, then it will, return. So providing function returns is not that value. This one returns nothing, so that would probably still work. This one deletes an operator. This one does. These are a lot of things too, don't they? There's a lot of functions here that actually do stuff. This one returns that error code. All three of these do that. This one also does. This one does something. Like this one has a few structs that we know the type of. So it takes a tfit engine and it takes the raw bytes secure data. Could this be it? Could this be the function we want? Let's create a function now. This looks like the actual create cipher. This is like the main create cipher. So let's create cipher. Maybe. So we all know all of these have to have this input structure, right? Let's go by with that. Let's try that. If any of these make sense. Any of these functions make sense. Does it do anything with the cipher variable? Does it do anything with... Well, first off, it checks a bunch of stuff here, but alg is just set to 2, so I don't know what that would achieve, but it would still work. T for engine is set to the handle, so that kind of makes sense, that the handle would be an instance of T for engine. That makes sense to me. Is the cipher variable used at all? No. Is the key data used though? No. But maybe it is on another one. You never know. Let's try to find what does this function do? Assuming this is the same at the back. Let's head over to here. Let's copy this function signature. Let's put it onto this function as well. Let's try to find the one that makes use of the key data. Whole bunch of freaking object-oriented crap going on here. It's really annoying to reverse. Okay. This one just returns a value. This one, same thing. This one, same thing. This one does something. It's 5 parameters, but I feel like we have more parameters than expects. Still, which is kinda annoying. None of these look like the right thing. So, is it still the wrong jump table? Don't even know at this point. Oh, that goes into the key data thing, goes into it. And says something with it somewhere, you know. Yes. Decrypt AES 128 UBC. So, times like this, I really wish I had OO Analyzer. And the AS buffer, it's like it takes in the cipher, right, on the process buffer. But that's like the one thing that seems to not be used at all. Was this AND cipher. Like, that was never touched by any of these functions. It takes, and the other ones, it was like using it as if it was like a bit field, but like they're just set to static values of 2, 1, 1, 0. Like, having a debugger, dude, would be so helpful here. Um, You have no idea. Alright. I think in times like these, the option is just to get another source. So that's something we can do. We can, if we wanted to, look at this function from somewhere else. So that's what I'm going to do. I'm going to open up PSM SDK. Alright, I'm gonna extract this. PlayStation Mobile SDK. And the reason behind that is that if I extract the PlayStation Mobile SDK, I can grab encrypt.dol, which is what makes the encrypted PSSE files to begin with. If I'm correct, the DOL master has OpenSSL statically linked. Detect static linked functions. There is some plugin you can use to detect what like functions are statically linked or something. Because if I remember correctly, the DOL has OpenSSL statically linked into it. The DOL I want is part of this SDK. It's in the tools gib. I thought it was on the tools gib. You know, I was fairly certain it was under here. I was pretty damn sure. If I look at PSM Signer GitHub. No, this isn't what I want. PSM Signer rejuvenates. There's two things both called BSM signer. That's the annoying thing. Oh, I closed my thing. Silica sand -5. I closed my what? Silica sand. Yeah, I know people are changing their PSM profiles to all white. I kind of made that available. Some people, I swear. PSM signer. I had a thought. I need to go from rejuvenate. Rejuvenate. Defend you. See, it always reads it from. It reads it from here. PSM Yib tools PSM encryptor. You know, PSM Yib tools Yib, and it should be right here, but it's not. Maybe his scripts to extract the PSM SDK in Rejuvenate or something. Maybe it does something special. I'm gonna just extract Rejuvenate, honestly. It has what I need to know. Where is the Rejuvenate folder? Here it is. So, we're going to just copy this into here. Set up that. Let's extract it this way. Where does it even get it from? Because if it's not in there, then where is it? It takes it from, it's from, no, it's in that directory, and it moves it somewhere else. Right. That makes a lot more sense. So we go, PSM Encryption 32. That's not bother for the driver, I don't care. You can go now. I forgot the file I wanted. So PSM Encryptor 32. This is what actually creates the thing, right? So if we drop this in here, we can get a better idea of what this is doing. Problem is this has OpenSSL statically linked into it. Ghidra. I swear I saw live overflow. Do a video where he used like some using IDPO signature files with API sig. Yeah, that's what I want. IDPO signature files OpenSSL. Yeah, either fiat signatures OpenSSL. That's what we want. Because I know it has OpenSSL. They opened this before. This is the thing that encrypts it. You say I'm trying to decrypt workhouse, decrypted workhouse encrypted. Just for now. Because maybe it will help us understand the crypto better. Maybe. Either fiat signature. Must be a plugin for us, right? Yep, there is. Brilliant. API sig.py. Let's save that into our Ghidra plugins. Visit that analyze. Just waiting for this to analyze. It's so slow because it has like a billion functions. Yeah. So many of them are from OpenSSL. That's like 3 billion functions and half of them aren't even used. Just because it includes OpenSSL like in it. This is the main function, right? And it doesn't do much. It calls like a few things and it returns. Like it's really that much going on, but there actually is like tons of stuff it does, OpenSSL and whatever. And also PSM signer lets us know like what the inputs are, so we have the string. Okay. So let's save that and let's edit this function signature because we know what it is, right? We know that the function is called encrypt. We know that it takes uh, a child pointer in file, child pointer out file, child pointer install path, child pointer int type, I guess, int ptr, and child pointer to dev pkcs12, pkcs12, pkcs12 size, 12 size, um, host kdbg, and host kdbg size. So there we go. Let's identify all of these OpenSSL functions using a fiat signature. Actually, let's see if we can figure out what version of OpenSSL it is first. And know it's got OpenSSL in there. Maybe it can identify itself somewhere. OpenSSL 1.01a. 1.02a, not quite. OpenSSL Windows 1.01a. Fiat signature. 1.01. 1.01. Why can't I find 1.01? The other one was close. Alright, this other one had just use this because this is really close to it anyway. So maybe because it's like really close, we'll find a lot of it. So what was that one? From what is the what call it? It's under function ID. Function ID. API sig. You're not gonna ask me what signature I want to apply? Yui? Okay, well. Fiat not defined. Print Fiat header name Fiat is not defined. Brilliant, it doesn't work. There's absolutely nothing. It's exactly what I wanted you to do. It doesn't even work. Name PS is not defined. Mm. Lines 122. What? Hello. Passing failed. Well, that's why it failed to pass it and then it got an error. So, I just have a bad signature? An SSL. Back better. What is the version again? We found it in strings, didn't we? It's 101A. This is 101F. So we just go back further. That's 100E. 101F. 101F. 101E. Logging maybe. 101C. No, 101A, we just have 101, and it goes 101C. Oh, let's just, probably as close as I'll find to it then. And it out. Passing failed. Really, none of this works. We won't find anything. It's not being helpful. This is all Windows. Yeah, signature. I need it to work. I've seen other people use this exact plugin and it works fine for them. So like, why can't I use it? OpenSSL. Crypto and T. 101. It's all version 101. None of these work. How do I use these with either? I'm gonna just use this with either. Either Pro. I'm gonna just do it with either. Okay, how can I tell what to use for that signature? Reload file. Let's find that one that was really close to the right version that we had. Where was it? OpenSSL. Not this one, the other one. So really close to the right thing. So, reload file. Yeah, it's signature file. Oh, it has a list for me. None of these are what I'm after. They don't seem to have open SSL. Yeah, they don't have open SSL. See, it's search. No open SSL. How do I add to this? Let's take that random give SSL Ubuntu whatever, and let's put that in here. Yeah, continue. So using it supposedly. Gonna find anything by using it or anything? Let's save this on the desktop, I guess. Build file, fiat signature. Open SSL. Why isn't it in here? Name sample library. Alright. Hey, it detected a few functions. Kinda didn't really help that much though. Thank you for nothing. Gee, this is detecting quite a lot here now, isn't it? A lot of stuff just came up. Some for a few CBC encrypts. XRFs from XRFs 2, XRFs 2. This cost references 2. Why didn't this function work? Why doesn't it detect this function? I know if I search strings, now if I search for, I can find the ID here, right? That's used in this subroutine. So this is basically the same so this is the IV. It says destination. It's the destination of this mem copy. Alright, of this mem copy here. Yeah, it's the destination of that. Is this this is ASCII to, it probably is. This is probably ASCII to bytes. Which means this this is turn, this is IV out, right? And this is just that's a different IV. So that's a different IV it could use. But in practice that one isn't used. So if the IV2 is equal to this, then you use it. But then it will always just copy over it again. Right? So it will use that one, but then it will mem copy over it again with this one. So I mean this is kind of irrelevant then, because this is what's going to actually be used. But yeah, that's when it calls the this must be get IV. Okay, so what calls get x with graph 2. So it's part of this function sub. CE data encrypt. E data. E data encrypt. Oh, this is read PKCS12, probably. My phone's also getting ASCII bytes. This time with this dead beef value. Heh, this looks familiar. What do you say? This is that one we were looking at before. You know. And this is the last one. This is child input file. Input file. Let's just copy the output file. Install path. PKCS12 size. Host KDG. Host KDBG size. Those are the variables. We've got these, which are potential. Taking these as guessing these are outputs. There's almost certainly an array. One, two, three, four, 5, 6, 7, 8, 9, 10. It's for adding more arguments. guess I'm not consuming any of these. Let's make that like 6,000. Allocation fail. Well, screw you too.